Hello everyone, this is the group Luiz, Felipe, Max, Vinicius, and Matheus, Tiago, and I'm gonna talk about the Sidecar pattern. So in recent days, microservices are being popularized for the development of distributed applications, and microservices have brought a new set of challenges due to their distributed nature. One such challenge is handling cross-cutting concerns such as login, authentication, authorization, communication, and etc. Those challenges may require a lot of boilerplate and third-party software on the final microservices, and since the core business logic of microservices tends to be very small when well designed, the boilerplate ends up using a considerable amount of resources of the final service, what require maintenance and are bug prone. So maybe there is a better way of handling such challenges than just appending the solution to the final service container itself.
So I'm going to talk about what is a sidecar, and the sidecar pattern can be viewed as segregating the functionalities of an application into a separate process. And it allows you to add a number of capabilities to your application without additional configuration code for third-party components. And as you can see in the image below, um, as the sidecar is attached to a motorcycle, in software architecture, the sidecar is attached to your application and it can extend the functionalities of the application. Sidecar can do. Basically, the sidecar can have some functionalities, and the most common ones are observability, that is measure the system current state, monitoring, like managing the operational workflow of the application, logging, store, search, analyze, monitor, and alert on like the application itself, or maybe some traffic coming and incoming the application, and also some configuration that the sidecar can do, like set up environments for the application or other settings. So the sidecar pattern is a single node made of two containers. The first one is the application container, which contains the core logic of the application. So this is the application itself, and it contains like the core functionality of the application. And in addition, there is a sidecar container that is used to like extend the functionalities of this primary application, and it runs alongside the main application on the same container group. And since they are in the same pod, the main application and the sidecar, it shares the same resources. So like the file system, this network, they are the same for both of the containers. Multiple copies of the same sidecar are attached alongside each of the applications, and all the incoming and outgoing traffic, network traffic for an individual service flows through the sidecar proxy. As a result, the sidecar is able to manage the traffic flow between the microservices, gathers telemetry data, and enforces some policies. The service by itself is not aware of the network and knows only about the attached sidecar proxy. So I think a good phrase to like describe briefly what the sidecar part is about. It's about separating cross-cutting operations from a microservice to reduce its internal complexity. So basically, what it does, it's like remove some responsibility of the application, and then the application can focus on doing what it's created to do. And then the sidecar like worries about some things like logging and monitoring. That is like secondary functionalities. And here we have an image that that describes how a sidecar works. And basically we have here, for example, three microservices, the A, B, and C, and each one of them has its own sidecar. And all the traffic incoming to and from the main application, each one of them, goes through the sidecar. And then it can redirect, the sidecar can redirect the network traffic to the right location, can collect statistical data, and also it can create some logs.
So sidecars are generally used when there is something that the microservice need to do, but that thing is not necessarily intrinsic to the core business of the service. And things like an ambassador, like the primary applications is an ambassador to handle the connectivity operation, like logging, routing, and etc. The ambassador can be executed as a sidecar, and also things like offload proxy. In a Microsoft instance, a proxy like Nginx is placed for handling static file serving in the servers, and managing the proxy caching. Another sidecar can monitor the environment and clear the cache when the cache needs to be invalidated, Also, adding HTTPS to the legacy service, we can add a sidecar proxy to receive the HTTPS request and forward them to a legacy service that uses HTTP. So this is also a sidecar pattern is also very useful when you are migrating your application from something like a monolith or a legacy system to something like microservices, right? You can just have a sidecar that sees if you are trying to execute a legacy code, and you can just forward the request to the legacy system itself. And this complexity is also extracted from the service itself, so it doesn't know if the request from a legacy service may never get to the microservice implementation itself. Also, a log aggregator, when each microservice generates analog errors, it might impact its memory and disk volume. In such cases, we can transfer the error logs from the microservice to a log aggregator sidecar. And also server-to-service communication. And when using a service mesh system, sidecars are often used as a way to connect it to the service mesh control plane to get information about where a requested service is running and automatically forwarding the request to them. So the microservice using sidecar to server-to-service communication doesn't need to know the URL or the IP of another service. You can just ask the sidecar to forward some requests to the target service, and the sidecars will automatically forward and get a response for the microservice itself. So the implementation becomes much easier, and it's also easy to maintain on a distributed environment.
Now that we have seen what sidecars are, as well as some use cases, let's talk a little about benefits of using sidecars. Well, one is that sidecars reduce the complexity in the microservice code by abstracting the common infrastructure-related functionalities to a different layer. We have seen a lot of things that sidecars can do, like logging, tracing, and other infrastructure tasks, and when you do that in a sidecar, the microservice code becomes less complex and smaller as well, so that's good. And sidecars also reduce code duplication in the microservice architecture, and this is because you do not need to write configuration code inside each microservice, right? So when we do that in a sidecar, we avoid to in every microservice write configuration code, and that's good as well. Also, sidecars provide loose coupling between application code and the underlying platform. And this is because the microservice will have less code of the specific infrastructure that it is on, which means less dependence, right? So when a microservice depends less on the infrastructure that it's on, it's good. You can move the microservice to other infrastructure if you like. But everything has a trade-off, like everything has downsides, and we will talk a little about situations that maybe is not good to use sidecars. One situation is that the inter-process communication needs to be optimized, which means that the communication between a parent application and a sidecar service the communication includes some overhead, and especially in the calls. They have some latency, and this may be not acceptable trade-off in some cases, right? Other situation, there is small applications where the resource cost of deploying a sidecar service for each instance may be not worth, right? You will need for every instance, and if it is small application, probably is better not implement that. And as well, when the service needs to scale different or independently from the main application, right? If the application, let's say, go from another way that the sidecar was built to, and this may be not good, we need to write another sidecar, and if you know that this is going to happen, maybe it's better not use a sidecar at all. Okay, before I finalize our presentation, we would like to talk a little bit about software that implements sidecars. There's a lot of software that do that in these days in the market, with different functionalities and capabilities. But in general, all these software are very interesting because you put your application on that and they do a lot of things for you. You need to just configure a little bit and you get like observability, monitoring, logging, load balancing. It's very easy to do that, and it's very easy. It's very good. Here we are exemplifying three. There are Envoy, Issue, and HashiCorp Console. HashiCorp Console are with traffic proxy, because with that you can get not only issue traffic, but north and south as well. That is very interesting. And here we have an example that what happened before and after you use the sidecar with Istio, right? So before, you can see that each container has a lot of things to do, load balancing, resiliency, tracing, and after you use sidecars, all becomes more easy, right? I mean, the container only have the service A, B, and C, and the other things sidecars are doing. So this is very good. Sidecar is very good. That's it, guys. Thank you so much.